Hello and welcome back. This is Greg French. Today we're going to discuss Chapter 4, Part 2, Form Factors, Power Supplies, as part of our continued A+ computer repair series. Measures and properties of electricity. Successful technicians, they understand electricity. They know how to use electricity. They know how to measure electricity. Can protect computer equipment from electricity problems or threats or hazards. Units used to measure characteristics of electricity. We have the volt, voltage, amp for amperage, ohm for resistance, and the wattage for power. Here's a chart that goes over the volts, ohms, current or amps, and the wattage. It's a good chart in the book. You should look at it, review it. AC and DC, two different types of electricity. The AC is our alternating current, stands for AC. Oscillatory current driven by alternating voltage. It's a generator, and then as the generator turns, the voltage forms a sine wave. It goes positive for a while, then it goes negative. Now these generators run at about 60 cycles per second, so they have 60 revolutions per second, run very fast. Direct current, DC, signal direction current driven by constant voltages. So this is a voltage that does not change, and this is what we need for our electronic components inside the computer, especially for our binary ones and zeros. 1 would be a 5 volts, 0 would be 0 volts. Required by computer in small amounts, again, such as the 5 volts for our logic rectifier. Rectifiers convert AC to DC, chops the voltage. So we only see a positive going or a negative going, not positive to negative. Transformer. Transformers change ratio of current to voltage. We can use a step-up transformer to increase the voltage, or step down to reduce the voltage. We'll talk more about that. Power supply acts as a transformer and both rectifier. So they have both transformers and rectifiers and some kind of a filtering device in there to get a good DC voltage. Here's a good little chart showing the transformer here in the center, power coming in and power going out. Depending on what we're doing, if we're stepping it up, we'll get more voltage coming out. If we're stepping it down, then we'll have less voltage. More current, less voltage. Transformer keeps the power constant. Hot, neutral, and ground. Completing a circuit. AC travels from a power station to a house on a hot line. AC travels from the panel to the device using a black or hot wire. So we use a black wire for a hot wire in the house. AC flows out of a device circuit to a white or neutral. So we use white as our neutral or return line. AC returns the power station on the neutral line. Short circuit. Short circuit be failure due to excessive flow of electricity. That's where we usually get a circuit breaker that blows. Fuses protect circuits by melting a wire. Inside a fuse, we have a little wire that does melt as it heats up with too much current. And that breaks the circuit. Grounded neutral lines pass detoured AC to earth. So if we do have a problem, we can pass the voltage back to earth. Lines in 3-prong plugs, hot, neutral, and ground. We can verify voltages, verifying the wire of outlets for plugs using some kind of receptacle tester. We'll show you an example of that. Normally, electricity flows from a hot to a neutral. Make a closed circuit in the controlled environment of an electrical device such as a lamp. So inside the lamp, we've got a light bulb, and we've got 2 wires connected to it, a hot wire and a neutral. And then the voltage flows across the element in the light, giving you light. Here's that receptacle for checking your circuits. This is used as a receptacle tester to verify that the hot, neutral, and ground are all wired correctly. And on the back of it here, there are some lights. And depending on how these lights light up, you can look at a chart here that's on top of it, and you can see if you have a miswire. Some common electrical components. Material is used to make components. Conductors. Conductors don't resist the flow of electricity. It says it weakly resists that flow of electricity. So coppers are good conductors. Insulators, however, highly resist the flow of current. So they're not very good conductors because they resist that current flow. Now, a semiconductor allows the flow if charged. We'll talk more about semiconductors. They allow a small amount of current to flow through, but if you charge them, you'll get a greater flow. Transistor, used to switch current. There's where we get our 1 or our 0 for our on and off states, our binary logic. Also used to amplify current. We can use them to amplify. Made of 3 layers of semiconductor material. Charge applied to the center layer, which controls the switching. Now here are some examples of some components. We've got the resistor, we've got the capacitor, a ground, a diode. Diode only allows the current to flow against that arrow, so it only goes in one direction. Now the transistor, we've got 3 elements here. We've got this, and the center one. Center one is what we charge. As we charge this, we can allow current to flow, depending on the charge, and that gives us our change our state up here from a 0 to a 1. We allow current to flow. Some common electric components. Capacitor holds an electric charge for a period of time, used to create even flow of current in a PC. So we can dampen changes out by using the capacitor, because it'll actually store voltage, and then that voltage will be added to or taken away from any changes in the line. A diode allows electricity to flow in one direction only, used what we call to rectify AC to DC. Now a resistor, that controls the amount of current flow, so we can reduce the amount of current flow by adding a resistor. We can change that by increasing the resistor or decreasing it. Now here we've got some examples of some capacitors in these cans here. Capacitors on the motherboard or in the circuit board often have embedded crossed lines at the top. Review. Properties of electricity. We talked about the voltage, the amperage, and the power, and the amount of power. AC and DC, 2 different types of voltages. AC is alternating current. DC is direct. Direct is what we need for the computers. AC is what comes into the house. Common electrical components. We talked about the resistor, the capacitor, transistor, diode. We'll talk more about these. These are just the common components used in a computer. And the transformer. Now, the transformer can be used to step up or step down voltages. Another important component. Activities. We're going to explain the differences of the common electrical components. I want you to be able to identify them all and discuss the differences. Lab 4.2, we're going to measure the power supply output. Look at what's going to come out of our power supply. It goes in 120, coming out we're going to find 12 plus or minus, 5 plus or minus, and another 3.3. I want to discuss what those are used for. There's some review questions I want you to answer. And that's it for Chapter 4, Part 2. Thank you very much.